So let's finish this thing up. And then we'll take a break. All right, interpret R always means the same thing. Is it strong positive correlation? Is it weak positive, weak negative, strong negative? So what would you say here? Strong positive correlation. What about if R would have been 0.3? No, it could be better than that now that I gave the number. You need this to show evidence of correlation. So if I was at 0.3, that's not even evidence of correlation. I can't even say they're correlated at all. It's not just weak, it's non-existent, right? You got to be here just to show evidence of correlation, period. Because maybe randomly they seem to be connected. You got to reach that bar to show that there really seems to be a true connection. And we reached that bar and went way beyond. So what about R 0.49? That would be weak positive correlation because it just barely went over the threshold. But 0.92, that's strong. Yeah. It's not perfect, but it's strong. What does it tell us about the line of best fit? I would accept a couple of things. Okay. So it's got a positive slope. I need something better than that.
It's generally tied to the line.
Good. The data points are tied to the line. That's one thing I would take. You don't have to say tied to the line if that makes you feel weird. Say whatever you want to that means that. The other thing I would accept here is, yeah, I can trust the line to make predictions. Sorry. Let's cut this guy's like, that line looks shifty. I don't trust that line. This line you can trust. This guy, that's its Uber rating. I don't know. Now look at this. Predict the median income for a state with that percentage holding a bachelor's degree. What do I do with that number? Plug it in. And we built this equation. Using percentage numbers. So we can actually put 37.6 in. In fact, we have to. So if I put this in, I'll put 1570.74 times 37.6 plus 1223 1.47, or you could do the second calc value thing, right? Either way you do it, I'm going to do it that way. Second calc value, and I can put in there a 37.6, and I get this prediction. See? I just talked about. Did we move the decimal over when we created the equation? So then to use this equation, we created it. So we're like, I'm going to let myself put percentage numbers in. That's how we created this. Most equations are created from decimal numbers. That's why most math equations we have to change it. I really want you guys to get that. We are creating this damn thing. We can make it do whatever we want it to do. So we predict this. What did Virginia actually is? What does this number have to do with Virginia?
It's the same.
It's they are a state with that. We predict for a state with that percentage having a bachelor's. We predict a little over 71,000 a year, and they got. Yeah, they got pretty much that. They were a little higher than we predicted, which is okay because R's not 1, so it's the data points are off a little bit. If they were if it was really far from our prediction, then we might want to look closer and see what variables are affecting it that way.
So what would we say for the compared to Virginia, like over?
Yeah, we would just say Virginia 71. What was it? There it is. 535, more than predicted. But predicted. Blah, blah, blah. Just actually show me you looked at it, right? You lose. The only way to lose points there is you leave it blank, or you write something that has nothing to do with the question. But just show me you actually looked at it, so you can see how close it is. If R would have been 0.7. Maybe that would have been a lot further off because then the prediction is not going to be as accurate. The closer R is to 1, the more accurate our predictions. Makes sense. Hopefully. What about this last question? Because that is one interpretation of this, right? One interpretation of this is, oh, having more people have bachelor's degrees causes them to earn more money. In fact, that's how I presented it earlier. What's another interpretation of this? Can you turn that around? Could income affect the percentage of people with bachelor's degrees instead, the other way? Yeah, because what's it take to get a bachelor's degree? Still, maybe not after this next election. I don't know. It takes money. Sometimes it takes a lot of money. You basically sign away the next 20 years of your life paying that back. Jeff lived that experience. I had $30,000 in student loan debt when I graduated, and I was not becoming a doctor, so that took a long time to pay off. Anyway, sorry. Do you guys understand? So I don't know. This doesn't tell me what affects what, or maybe these both are affected by some third thing. This is not that deep of an analysis, but it's a really good introductory, like first step analysis of something. You guys semi with me? So that's basically what this class is, to be honest, is just we learn a lot of first step analysis. Hypothesis tests are kind of like some deeper stuff we do, but most of what we do is first step analysis of unknown data. And this is one of those. Maybe. Could be. All right, let's take a break. Okay, I think you're okay with that. I understand. Then when we come back, we're going to get into chapter 11.
What time do we come back?
Oh,